know the relationship between Ks, solubility constant, or solubility dissociation constant, and its solubility. And one of the first things that I sort of think about is you can write an expression for one and you write an equation for the other. So you write an expression for Ks. So that's our Ks equals, and it's the equilibrium expression that we can write with the square brackets and all that sort of thing. Solubility is found from the actual equation itself, because a certain amount will dissolve and a certain amount won't. Because if any more dissolves, then the reverse reaction happens to precipitate some of it out, hence it being a dynamic equilibrium. So from here we need to get units, from here we're not. Alright, so that's one of the first things I want to point out. In Ks, there are units, but in level 3 you're not expected to know what they are. Alright, so disregard units for Ks. But solubility is telling us in grams per litre or moles per litre how much is actually dissolving. So it does have units, and I'll put those down the bottom, and the relationship between them. Because in a question you might be given the solubility in grams per litre or moles per litre, or it might ask for it in one or the other. You need to know how to do that. If you're working from Ks, you'll find it in moles per litre, and then you might have to turn it into grams per litre. Get to that in a moment. Okay. Yesterday when I did the overview, the context I used was copper carbonate. So I'm going to go back to that one there. And the experiment we did yesterday, well, not experiment, the little demo where I put some in water to make a saturated solution. What I had there, it was about 20, 21 degrees Celsius in here at the time. So I looked up the Ks value for copper carbonate to find out how much did actually dissolve. So there are a whole lot of numbers there, and I took the one at 20 degrees Celsius because it was the closest to what the room temperature was then. There are a range of them. So Ks values are dependent upon temperature as well. And then I wanted to find out, well, how many moles per litre of the stuff actually did dissolve? And then I could have gone on to grams per litre later. So I know that a certain amount did dissolve. I'm going to call that S, simply because it's Ks. Okay, you might call it X because you can see this is algebra we're about to work with. You're not going to be marked wrong for putting an X there, or a Y, or a Z. I'm just using S because I'm working with Ks, that's all. Okay. So S moles per litre will actually follow the forward arrow, will actually dissolve. And looking at the fact there's no numbers in front of anything there, that means that S moles per litre of copper carbonate ions are in solution, and S moles per litre of carbonate ions are in solution. There's nothing else affecting it. I didn't add any other chemicals into the mix. It was just those and water. And that says water because they're AQ. I looked up the value and found that it was 1.40 times 10 to the negative 10. So therefore what I did is I wrote my Ks expression for this. Why didn't I include the CuCO3 in this? Why didn't I include it? Because it's a solid, good. It's not AQ, it's solid, so I disregard it. Well, if both of these are S, S times S is S squared. Again, why it might be easier to use X for you. You might find it easier to use X because that's the way you've been taught in maths. I therefore can say, okay, well, S squared and 1.40 times 10 to the negative 10 are the same. So I'll rewrite it this way. Well, I need to know S, the solubility, how much did dissolve. So I'll do the square root of both sides, and I get my answer. You'll notice that now a unit comes in, and it's moles per litre. Now I could then convert that into grams per litre by multiplying by the molar mass of copper carbonate. About 123.5, I think. And then I'll end up, I could actually look that up on the internet and actually find that I get the number they give on the internet, which is always in grams per litre. I've underlined these three numbers for a reason. Could anyone guess why I've underlined three numbers? By those three numbers there, three numbers there, it's three numbers all the way through. Why? Good. An excellence criterion is that you will give your final answers, not your working, your final answers to three significant figures. So you have to do that. Okay? This is all really nice and easy because it's all a 1-to-1-to-1 ratio. What happens if it's not? Now this is the one from your book. So if you did do the reading last night, I'm just going to unpack the one in your book a little bit. Where it has silver chromate becoming 2 silver ions and 1 chromate ion. Again, S moles per litre will dissociate, making 2S moles per litre of silver ions in solution and S moles per litre of chromate. So we use our balanced equation to start our algebra, as it were. Again, we're also given the number. I wasn't happy with your book because it only gave 9.0. It really needs to be 3 significant figures if your answer is going to be. However, because it's a constant, for those doing physics you probably know this, it doesn't matter how many significant figures are in your constant, it's about the precision of your equipment. Okay, so if they give 8, you can still only go to 3, and so on. But likewise, they only give it as 9.0, we'll still give our answer to 3. Okay, so what I do then is I write my expression. Now you notice the 2 in front becomes squared. Okay, so the way we would write it is Ag plus times Ag plus times Cr04 to minus. Because we could write that as Ag plus Ag plus chromate. Okay, so that's why it's squared. We also, though, have to put inside that not S but 2S, because it's the amount, it's the concentration that is made. So if this is 0.1 moles per litre, it's not, but let's say it was 0.1 moles per litre actually did dissolve, this would be 0.2 going into there, and that would be 0.1 going into there. So just be aware of that. So therefore, if I've got 2 of one thing and 1 of another being made, I end up with this 4s cubed as my, or 4x cubed if you prefer that. And this is because the 2s gets squared. The 2 gets squared as well as the s. And then I multiply it by this one. Any questions on that one? Because this has always confused me when I was at your age as to why we account for the 2 moles per litre twice. All good with that? Just going to trust it to be true? Okay. In short, for those who aren't confident to say it, the 2 is telling us how many moles per litre there are effectively, but we don't know it, so it's an unknown S. The expression doesn't care how many moles per litre there are, as it were. And you'll see that when we do ionic product. It actually doesn't care how many moles per litre there is. It's just a rule, as it were. So the Ks values are just a rule. So therefore, answering this is a little bit trickier. We have to first of all divide both sides by 4, and then you have to find where your cube root button is on your calculator. So if you don't know where it is, that's one of the first things you have to look up. Again, we solve it, so we go divided by 4. You notice I put brackets there. This is how to put it in my calculator. Okay? I would go cube root bracket 9.0 explaining negative 12 divided by 4 bracket equals. Otherwise, you'll end up just doing the cube root, the 9 times 10 to the negative 12, and then dividing your answer by 4, and that's not correct. You divide by 4 first, then cube root. So our brackets allow for that. And that gives us this value here. Okay, any questions on that before I swap the boards over? Because I've got one more skill you need to have. Right, lucky last. This one is the easier one. I've actually done the hard one first. This one's easier. If I know the solubility, then I can find the Ks value. So I start with my equation. Always start with an equation, because then I know what's solid and what's aqueous. I also know how many moles of everything are going to be included. So if I know that 2.30 times 10 to the negative 4 moles per litre will dissociate, will dissolve, then looking at the numbers in front of what's made, I can put the moles per litre of these ions that are in solution. So there's no number there, so they'll be the same. But notice the 2 in front of here. I have to double this value for this one. And that might help you understand what I just did before with the 2s thing. Then I write my Ks expression, and I just simply plug those numbers in. Now the biggest error that students make in exams is they forget to double that number before they put it there. So my recommendation to you is to write the numbers under the species in the equation as part of your working. Then you know you're putting the right numbers in, but also the examiner can follow your thinking a little better. Okay, so you write the Ks expression, you then put the numbers you're using in place. So if you had it written correctly there, but forgot to transpose that number into there, you might not get knocked too heavily for the marking schedule. Then we just solve it, and you'll notice there's no units for this one. But again, we've stuck with the 3 significant figures. Okay. As I say, that's the easier skill, but the trick is the one in green there. Any questions on that before I stop this? Awesome.